In this demonstration, you'll learn how to perform a basic fluid flow simulation using a template. To begin, from the list of simulation process templates, I'll pick fluid flow, and there are some options if I want to customize the template. I know for the geometry I'm using, the flow volume will need to be extracted, so I will choose that and create the simulation process. I'll pick my geometry, click Open, and AIM will use that geometry in the template to build an outline of a fluid flow simulation. The geometry is now visible. It is a manifold with 3 inlets and 1 outlet. I can also see that the template has produced a number of tasks, many of them incomplete. This is the advantage of using a template, that the framework of a basic fluid simulation is automatically created. I can still customize the simulation process to meet my needs as I go. To start, I see the geometry task is complete, but the next task in line needs attention. So I'll click the volume creation task in the workflow view at the bottom. I can see that the extracted volume under volume definitions requires attention. The body's bounding flow region has been set automatically, but I still need to create a seed point and move the seed point inside the flow region. To complete the volume creation task, I need to cap the openings of the manifold to further define the flow region. To do this, I'll use this Next Step button. I can see it is telling me, by highlighting in blue, that I need to add some capping surfaces. I will be defining these capping surfaces by choosing adjacent faces. This is convenient for the geometry I am working with. Holding down the Control key, I'll select the 4 faces at each opening of the manifold and use these to define my capping surfaces. I now have everything I need to complete the volume creation task, so I will return to the task page and click Create Volumes. Now the flow volume will be extracted from my solid model. Notice there is a progress indicator in the lower right-hand corner. And now the flow volume has been created. Moving along the workflow view, the next task I need to complete is the meshing task. The fluid flow template has created an inflation control, as most fluid flow cases would require inflation to model boundary layer effects. I need to pick a location for the inflation layers, and this needs to be the inner wall of the manifold, which corresponds to the outer wall of the fluid volume I just created. The rest of the defaults are fine, so now I just have to right-click the meshing task and update. Now to the physics task. There are a lot of options in the physics task, but by using a template, many of them have been set for me. For instance, since we are using a fluid flow template, a fluid flow physics region has been created. This defines what type of simulation will be performed and where the corresponding equations will be solved. Currently, I am only solving for the flow field in the manifold. If I was interested in the temperature field, I could also activate thermal here. But for this demonstration, I'll just stick with fluid flow. Now back to the physics task. I also want to check what material the template has assigned for me. It has used air, but for this simulation, I want to use water. I can see the properties for water by expanding this panel. Returning to the physics task, I see by the blue button that I need boundary conditions, but I'll close the panel and use an alternative method to add these. I'll select this face and right-click. I'll go Add, Boundary Conditions, Inlet. Now a small property panel appears and I can enter some information about the inlet boundary condition. I'll enter velocity magnitude of 5 meters per second and press Enter. The icon on the model tells me that an inlet boundary condition has been added on this face. I can edit the boundary conditions by just clicking on this icon, and the property panel will reappear. I'll repeat this process for the other inlets, using velocities of 7 and 10 meters per second respectively. I'll select the opposite end of the manifold and assign it an outlet with a gauge static pressure of 0 pascals. Finally, I'll create a wall boundary. By default, this will be assigned to all the faces which have not previously been defined by boundary conditions. Now all 5 faces are assigned a boundary condition, and I can proceed. Returning to the physics page, I can see that the physics task is no longer in a state of attention required, but now out of date. This means I have fully defined the task and can now solve the physics. I can monitor the solve by opening the Solution Quality tab and watching the residuals update after each iteration. There, the solver has finished, and we can move on to the results task. The fluid flow template has created a result for me. It is a vector plot. All I have to do is update the results task to see it. And here it is. It looks a little sparse, so I'll increase the number of symbols from 100 to 500 and reevaluate. I'll show faces and enable transparency just to improve the visualization. And that completes this demonstration of using a fluid flow template in AIM.